for Section 10, Anti-Derivatives. I'm your host, Dr. D. Okay, let's get going here. Anti-derivatives. Okay, what is an antiderivative? Capital F is the antiderivative of small f. That means the derivative of the antiderivative is the original function. So what we're doing now is like back when you were in early elementary school. You knew how to add, but then you were told there's subtraction. You have to go backwards. Then you thought you were cool knowing your multiplication tables. Then they said, there's division. Okay, so you just learned your derivatives, and now there's antiderivatives. Not impossible. We could do this. Okay, so here's the deal. We just have to think backward. So, if we have a function x squared, we want a function that if we take the derivative of that, we get x squared. So we want the antiderivative of x squared. Well, think about how you get a derivative. You take the exponent and put it down in front and then drop it by 1. Well, so we're going to go the opposite direction. We're going to increase the exponent by 1 and then we're going to divide by that number. Okay, so let's do this. So f of x, capital F of x, would equal x to the third over 3. Now, there's an important thing that you have to understand here. Every antiderivative has to have a plus c at the end, which is a random constant. It could be anything. But you have to remember to put plus c at the end. Now watch. If I take the derivative of this, what do I get? Well, let's just make this, instead of x cubed over 3, we'll make this 1/3 x cubed plus c. Now I take the derivative of this. I go 3 times 1/3, which is 1x squared. Now the derivative of the constant is 0. So basically if I take the derivative of my antiderivative, I'm back to my original function, x squared. Okay, so if I have the function x to the n, let's make our antiderivative of any x to the n. That means basically we're going backwards from the power rule. So, f of x, the antiderivative, is going to be x to the n plus 1 over n plus 1 plus c. Now, this is basically, like I just said, the power rule in reverse. And this is super important to understand. We're going to be using this the entire rest of the year. So if you have a function x to the n, then you raise the exponent by 1, and instead of multiplying, you're dividing by that exponent. And do not forget plus c. If you forget plus c, there could be dire consequences. Okay. All right, now, let's try the next problem. F of x equals 1 over x. Now, 1 over x equals x to the negative 1, right? So if we use the inverse power rule, then I would go x to the negative 1 plus 1 would be x to the 0 over negative 1 plus 1 would be 0. X is 0 over 0? I don't think so. So what will I do? Well, let's just think. What is it that when I take the derivative, I get 1 over x? It's natural log x. So see, the antiderivative then would equal natural log x. So, oops, and I forgot plus c, of course. And so if I take the derivative of natural log x, I get 1 over x. Bam! Okay, now what if my original function is sine x? What's my antiderivative? So basically I need something that when I take the derivative of it, I get sine x. Well, you might think, oh, it's cosine x. Well, no, because cosine x, the derivative is negative sine x. So that means the antiderivative of sine x has to be negative cosine x, plus c, of course. Now when I take the derivative of negative cosine x, I get positive sine x. And we could go on if f of x equals cosine x, then capital F of x equals sine x plus c, of course, because the derivative of sine is cosine, so the antiderivative of cosine is sine. Then I know if f of x equals tangent x, well, okay, there's no way I can get the antiderivative of tangent x. But I can get the antiderivative of things that I already know the derivative of, right? So the derivative of tangent is secant squared. So that means if the original function is secant squared x, then the antiderivative of secant squared x is tangent x plus c, of course. Derivative of tangent, secant squared. The derivative of cotangent is negative cosecant squared. So that means the antiderivative of negative cosecant squared is cotangent, or the antiderivative of cosecant squared would be negative cotangent plus c. Now, see, we're just thinking backwards from what we already know. Now, we don't know how to get the derivative or the antiderivative of secant yet. We will later on. Now, what if the original function is secant tangent? Then that means my antiderivative has to be, right, secant x plus c, senor. Okay, so the derivative of secant is secant tangent, antiderivative of secant tangent is secant. And if the original function is cosecant cotangent, then notice the antiderivative has to be negative cosecant x plus c. So there are your trig functions. You know the derivative of sine is cosine, so the antiderivative of cosine is sine. You know the derivative of cosine is negative sine, so the antiderivative of sine is negative cosine. You know the derivative of tangent is secant squared. You know the derivative of cotangent is cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant, negative cosecant cotangent. So now one last thing. If f of x equals e to the x, well, you know the derivative of e to the x is e to the x. So that means the antiderivative of e to the x is also e to the x plus c, senor. Okay, and are there any others that we're missing? Oh yeah, there's a couple of juicy ones here. If the original function is 1 over 1 plus x squared, okay, if f of x is 1 over 1 plus x squared, what is the antiderivative? In other words, what function gives us a derivative of 1 over 1 plus x squared? Right inverse tangent x. And that's going to be hugely important. When you see the function, you want the antiderivative of 1 over 1 plus x squared. The antiderivative is going to be inverse tangent x. And let's just do this also while we're at it. So I've got the f of x equals 1 over the square root of 1 minus x squared. And that means the antiderivative is going to be right inverse sine x. Okay, so those are the important things. You've got all your trig functions, you've got your log functions, you've got your exponentials, and you've got your inverse trig functions for your antiderivative. So it's time to learn those just in case you come into class sometime and there could be possibly a quiz! Okay. So, cruising onward. Now I'm trying to keep this lesson short, but there's just I need to make sure you understand certain things. So, I'm given f prime and I want to find f of x. So basically we're finding the antiderivative. Now, there's no way you can do a quotient rule in reverse. So don't even think about it. You have no capability of getting the antiderivative of a fraction. But this is no ordinary fraction. Now you can change this into a bite-sized chunks that are added up. So let's just do that. So this equals 2x to the 5th over x minus x to the 1/2 over x. See, all I did was treat this x as a common denominator, split those two things up. Now, 5 minus 1 is 4, and 1/2 minus 1 is negative 1/2. And I could have made this 1 over the square root of x, but the thing is I'm trying to do the antiderivative, so I'd rather leave it as a fractional exponent. So, now the antiderivative of this is going to equal 2x to the 5th over 5. Remember that? You just move the exponent up one and divide by that same number. And now, minus x to the raise it up 1, that would be 1/2 over 1/2. So that means we've got 2x to the 5th over 5 minus 2 square root of x plus c, senor. And I actually should put the c up here too. But don't forget, that's always part of your final answer. And if you forget it, if you don't have a plus c there, then you know hackage will ensue. Don't let that happen to you. Okay, so there's your final antiderivative. Now, if you want to find out if you got it right, take the derivative of this, and you'd have 5 times 1/5 is 1 times 2x to the 4th. So there's your 2x to the 4th. And then you're doing the same thing. You're taking the 1/2, putting it down in front. 1/2 times 2 would be 1x to the negative 1/2. And that would be x to the negative 1/2 which would be what we had originally. Okay, that's it. Now, this next one, we've got an e to the x here. F prime is e to the x plus 20 times 1 plus x squared to the negative 1. Now, they're also giving us what we call initial conditions. F of 0 equals negative 2. So here's what we're going to do. We're going to do the antiderivative first. So antiderivative e to the x is e to the x. Now, what's the antiderivative of 20 times x times 1 plus x squared to the negative 1? Well, this really is, wrong side, okay. This really is 20 over 1 plus x squared. So, do you remember seeing something like that? Yes, the antiderivative is going to be 20 times inverse tangent of x. 20 inverse tangent of x plus c. Now here's where we use the f of 0 equals negative 2. What this is saying is when x equals 0, then the function equals negative 2. Oops, I messed up. These things are not, f prime is this, so that means these are not capital F, these are small f's. We'll edit that out. Okay, so the derivative is this, the antiderivative is small f. So the derivative is this. Now the antiderivative is the original function then, and that's e to the x plus 20 inverse tangent x plus c. Now, if f of 0 equals negative 2, then what that means is negative 2 equals e to the 0 plus 20 inverse tangent 0 plus c. Well, now I can solve for c. So e to the 0 equals 1. And inverse tangent of 0 equals, well, think about where is tangent equal to 0? At 0. So tangent of 0 is 0, so that means we have e to the 0 is 1, 20 inverse tangent of 0 is 20 times 0 plus c. So that means c c equals negative 3. So now I go back up to my original function, and I now say f of x. We don't have a c in it anymore. There's no general constant because we solved for the general constant. So f of x equals e to the x plus 20 inverse tangent of x plus or minus 3. That's my final function, and I don't need the c because I solved for c. Okay, let's see if, yeah, that's actually what the book got too. Okay, that's happy. All right, now, next one, we're looking for the second derivative, or I'm sorry, we're looking for the original function given the second derivative. And we're given two initial conditions. So, make sure I copied that right. Yeah, that's right. Okay, so now, first thing we do is we have the second derivative. I want the first derivative then. Well, that's going to be the antiderivative of the first derivative. So, I go, that's 12 x cubed over 3 plus 6 x squared over 2 minus 4x plus c. So f prime of x equals 4x cubed plus 3x squared minus 4x plus c. Now, if I take the derivative of this, I get 12x squared plus 6x minus 4. Now, we know that f of 0 equals 4. So, oh no, we got to do one more step. Okay, yeah, one more step now, and we say f of x is the antiderivative of f prime of x. So now what I do is I say, okay, fx is going to be 4x cubed, or I'm sorry, 4x to the fourth over 4 plus 3x cubed over 3 minus 4x squared over 2 plus cx plus d. Okay, so f of x equals x to the fourth plus x cubed minus 2x squared plus cx plus d. Now notice, let's go back and do this again. Take the derivative here, you get 4x cubed, derivative here 3x squared, derivative here is minus 4x, and derivative here would just be c plus 0. So anytime you get the antiderivative, if you just take the derivative of it to make sure you're back to where you started, then you'll make sure you didn't mess up. All right, now, if f of 0 equals 4, then what I'm going to do is I'm going to put 4 in for f of x and 0 in for all the x's. So what I have is 4 equals 0 plus 0 minus 0 plus 0 plus d. Oops. That's a bad d. Okay. So what's that tell us? Well, d equals 4. All right, so really then, our function, we can write it f of x equals x to the fourth plus x cubed minus 2x squared plus cx plus 4. Now, last thing, we know f of 1 equals 1. So what I'm going to do is I'm going to put 1 in for f of x, and I'm going to put 1 in for all the x's. So there's 1 plus 1 minus 2 plus c plus 4. Okay, now I have all numbers except for the c. So I can now say that c, let's see, 2 minus 2 is 0 plus 4, so I subtract 4 from both sides and I get c is negative 3. Let's make sure that's right. 2 minus 2 is 0, negative 3, and 4 is 1, 1 equals 1. Yes, that's right. So my final answer is f of x equals x to the fourth plus x cubed minus 2x squared plus cx, which means minus 3, rats. Oh, that just burns. Minus 3x plus d, which is 4. Bam, there it is. So, you realize then what we need to do is we take the derivative once, and that gives us an unknown constant. Or not the derivative, we take the antiderivative once. That gives us the unknown constant c. Then when I take the antiderivative again, I get the unknown constant d. Now, you have 2 unknown constants. That's why they had to give you 2 initial conditions. And it really doesn't matter which one you plug in first, although, yeah, if we had plugged in f of 1 equals 1, then we would have a c and a d in the same equation. when I went f of 0 equals 4, that means that got rid of the c, so I could solve for d, and then I could find the other one, so it's a little bit easier that way. All right, one last problem. It's going to be similar to this. Oh, no, I'm sorry, two last problems. Okay, this problem is similar to this. The acceleration of a particle is 6t plus 4. The initial velocity is negative 6 centimeters per second. So clearly this particle is in France. Then the initial position is 9 centimeters. Now what we want to do is find the displacement function as a function of time. All right, so notice the derivative of velocity with respect to time equals acceleration. So that means the antiderivative of acceleration derivative and likewise the derivative of displacement is velocity, so displacement is the antiderivative of velocity. Okay, so if I want the velocity, then I take the antiderivative of displacement, so v of t is going to equal 6t squared over 2 plus 4t plus an unknown constant. Now, that means, let's just go on with this. This is going to be 3t squared plus 4t plus c. Now, the displacement is the antiderivative of velocity, so we've got 3 times t squared over 3 plus 4 times t squared over 2 plus ct plus d. Now, this equals t squared plus, wait, something has gone awry. Okay. Oh, t cubed, yeah. I forgot to put the exponent up one. So when I had 3t squared, it becomes 3t cubed over 3. So now I've got t cubed plus 2t squared plus ct plus d. Okay, and that's my displacement function. Notice it has c's and d's in it though. But this is what we're going to use our initial conditions for. Because if the initial velocity is negative 6, initial means at the beginning, which means when t equals 0. So what I can say is this is v of 0 equals negative 6. And initial displacement is saying s of 0 equals 9. Now, so I could have taken v of 0 as negative 6. And now what I do then, if v of 0 is negative 6, then what I'm going to do is I'm going to put a negative 6 in for velocity. And I'm going to put a 0 in for t. So this is going to be 0 plus 0 plus c. So then, that means that my velocity as a function of time really equals 3t squared plus 4t minus 6. Now, I go down here, and this isn't just plus ct, it's going to be minus 6t. Because that's what I just found out my constant was. And then this becomes minus 6t also. Now, I need to find d. Well, if f of 0 or s of 0 is 9, then that means 9 equals 0 plus 0 plus 0 plus d. So that means that d equals 9. And so now my final function is s of t equals t cubed plus 2t squared minus 6t plus 9. That's it. Now, just remember, anytime you want velocity from acceleration, take the antiderivative. Anytime you want displacement from velocity, take the antiderivative. You're going to have a constant. That's why they give you initial conditions, so you can plug in t equals 0 and find that constant. All right, now one last problem, and it's really similar to this also. A ball is thrown upward 48 feet per second, and it falls off a 432-foot cliff. So we're at 432 foot, and the ball gets shot upward at 48 feet per second, and then so it goes up above the cliff, and then it drops straight down to the bottom, 432 feet below the edge of the cliff. We want its height at any time t. Now, height is position. That's displacement. And one other thing you need to understand is, in our convention of physics, up is positive, down is negative. Now, in physics class, they gave you formulas. Now, actually, formula is for babies. So you don't need formulas. You derive your own. You're able to now cut your own meat. You don't need to be hand-fed. You don't need your mommy to cut your meat for you. So, the thing we start with is acceleration. Because this is the Earth, and this is also the good old United States of America, where we deal with feet and seconds. So what is acceleration in the United States of America? Acceleration of gravity, which we'll call g, equals 32.174 feet per second per second. Now, you were told that acceleration of gravity equals 9.81 meters per second per second. That's only in France. Okay, in the United States, it's 32.174 feet per second per second. Now, our book calls it just 32. I'd like you to actually learn 32.174 feet per second because that's what you're going to see in college. So just remember that number. And you might only know 9.8. It is actually 9.806 meters per second squared. Most people just round that off to 2 decimal places. So, okay. Now, the acceleration that we're dealing with is downward. So that means it's, well, let's write it like this. Acceleration as a function of time is negative, negative 32. Oh, come on. Acceleration as a function of time is negative 32. We'll just drop the 0.174 just for simplicity. So it's acceleration is negative 32. Now we're looking for displacement, so we need velocity first. So we take the antiderivative of acceleration, and that's going to be negative 32t plus some constant. Well, what is our constant? Well, the ball is thrown upward 48 feet per second. So what that tells us is that v at time 0, well, that's obnoxious. We'll have to edit that out. So v at time 0 is 48, and it's going upward, so it's positive. So that means my that means my velocity, 48, will equal negative 32 times 0 plus c, which means c equals 48. So that means my velocity statement is negative 32t plus 48. That's my velocity. Now, when, let's just go on. Let's go ahead and get displacement. So displacement, but let's package this because we're going to need this later. Displacement then is going to be the antiderivative of velocity. So that's negative 32 t squared over 2 plus 48t plus, we'll call it d because it's a second constant. You could call it c sub 1 or c sub 2 also. But now we know that the initial displacement is 432 feet. So just make sure that's the way they're doing it. Yeah, okay. So initial displacement is 432 feet. So that means we go 432 equals negative 32 times 0 plus 48 times 0 plus d. So that means d equals 432. And that means that gives us s of t. The position at any time t is going to be negative 32t squared over 2, which is negative 16t squared, plus 48t plus 432. All right, now, like I said, in physics, they would have given you formulas to get these. Now, we've derived our own formulas simply by anti-differentiation. And that's basically why Sir Isaac Newton developed calculus. The apple hit him in the head. He had to find out what the velocity of that apple was when it hit him. So that's it. Okay, now, find the height at any time. Well, here it is right here. Any time you want. If we put in t equals 0, the height's 432, just like we thought. It's right at the top of the cliff. If we put in, say, 5 seconds, then I'm going to find the height at 5 seconds. So let's say 1 second makes it easier. 48 minus 16 is 32. 464. So the height in 1 second is 464. Okay, so when is this ball at maximum height? Well, maximum height is where the velocity is 0. It goes up and comes back down. When it's 0 velocity, it's maximum height. So all we do to find maximum height is set velocity equal to 0. So I'm just going to go negative 32t plus 48 equals 0. And that means 32t equals 48. And that means t equals 48 over 32, which equals let's see, 16, yeah, they both go in 16, that's 3 halves. So at 1.5 seconds into this ball's flight, it reaches maximum height. Now, what's the, so we've got, there's the height at any time, here's the maximum height, the time of the maximum height. And then when does it hit the ground? Well, when it hits the ground is when s equals 0. So all we do is set s equal to 0 and we solve for t. So that means, well, let's just bring all this stuff over the other side. So 16t squared minus 48t minus 432 equals 0. And let's see, does 432 divide by 16? Yes, it does, because 32 divides by 16 and 400 divides by 16. So, yeah, let's just make sure. Yeah, so that's 27. All right, so if we factor or divide the 16 out of that whole thing, then we've got t squared minus 3t minus 27 equals 0. So what multiplies to get 27 and adds to get -3? Nothing. Okay, so we basically have to use quadratic formula for that, and you end up with negative, or with 3 plus or minus 3 squared 13 all over 2. And clearly t can't be negative, so it's got to be just 3 plus 3 squared 13 over 2, which turns out to be approximately 6.9 seconds. Now, as in all physics problems, you should always compare your answer with your intuitive feeling of it. Think about 432 feet, and it's actually getting shot upward from there, so it's a little higher than that. So, you know, if you think about a 500 feet drop, is it reasonable that it takes a ball 6.9 seconds to fall 500 feet? Yes, it is. Now, if we said this took 70 seconds, that's ridiculous. Or if this took 0.7 seconds to fall 500 feet, that's ridiculous. So 6.9 seconds is a reasonable time to get that to happen. Okay, that's it. Have fun with these.